Hey folks, and welcome back to another video. If you've been following my YouTube channel for a while now, you might know that I'm working on Project Slide, which is this game that you see in front of you right now. And you might also know that I'm using my own game engine and tools to create it. And lately we've been spending a lot of time in previous videos working on the game itself, creating assets, designing levels, even doing a little bit of narrative design, arguably. And all of that is really great fun, and I like doing it a lot. But every now and then you have to open up the hood of the car, so to speak, and poke around on the engine a little bit. And that goes doubly for projects where you use your own engine and tools. And I think the time has come for me to do that again. So this video series will concentrate on that part of game development. And in this case, particularly material editing. So I've come to the conclusion that my current way of editing materials in this engine is really quite bad. And that's something that I've mentioned a little bit in the previous videos whenever we've done any kind of material editing, but I've kind of had the belief that a solo developer such as myself can deal with material editing being a little crappy as long as I get the job done. But I think that might not be such a good idea after all. First of all, it slows down my own development quite a lot, and if and when I actually get other people to help out with finishing the game, they're not going to deal with my crappy tools. I've been thinking about this for so long now that I think it's just finally time to actually sit down and work out something better. So before we look further into that, though, let's just quickly review what the material is in this case. So we have, actually we can do like a free camera here, like this. In this case we're talking about visual materials. You also have physics materials. A physics material describes things like how slippery the surface is, or if a certain type of object can pass through another, stuff like that. We don't mean those here. We are talking strictly about visual materials now. And essentially everything you see here on the screen has a material attached to it. Some of these objects might be copies of one another. I'm sure some of these rocks are, for example, duplicates, and they use the same material then. But everything has a material, and the material describes things like what color is an object, and how reflective is it, and does it cast shadows, is it transparent, that kind of thing. And we've briefly looked at how to create materials in the Basis game engine in previous videos, and I'll show you how it's currently done. But before we do that, though, let's look at what I would like to have. So here we have the Godot game engine, and bear with me here because I'm not really good at using this. I've used it for about 15 minutes, so just enough to play around with this material editor a little bit, but nothing more. So here we have a sphere, and this sphere has a material that I created attached to it, which is this new material, new shader material here. And if we go look at the shader, we can double click this, or click it rather, we get this node editor down here. And this is where you essentially do your material editing, at least most of it. There's also some things here on the side, such as like cull modes or different lighting equations and whatnot to set here. This has to do with how the depth is sorted when drawing the scene, so that you get transparent objects on top of other and stuff like this. But actually describing the look of the material is done using this node editor here. And now this particular material has a vertex pass and a fragment pass. I'm not exactly sure what this lighting is here. Probably has to do with if you want to tweak the actual lighting model, but let's just look at the fragment for now. So as you can see, it is red. Let's try to get rid of that gizmo there so that we can see it a little better. And it is red because I have this vector here, which is XYZ, corresponds to RGB. So this would be the red channel. If we zero it out, the sphere turns black. And if we put it back, it turns red, and we can make it yellow like this. And of course we can also tweak these values a little bit. And you see the change immediately on the screen. So that's nice. So some things to realize here is that what this node graph actually produces is constants like this. This is essentially the same as sending a value to a shader as an input, which has the values 1, 0.4248 and 0. And the other thing that the graph generates is the actual logic. So for example, we can put in like a vector operation here like this, and we can reconnect this to go through. Here we have an add operation, for example, but let's put another vector constant here, and what should we do? Maybe we should make it slightly blue. So we add these together and we get like a slightly bluish tone. You can of course also multiply, and then this should now make it black, because 1 times 0 is 0, 0.248 times 0 is 0, and 0 times 0.5 is 0, so it just comes out as all zeros. But here we can actually see the generated code from this, and you can see, okay, we actually have constants here, and we have logic here. We have this is now a multiply, or if we add it, put it back to an add, this becomes a plus again. So this is really nice. I don't have anything like this, and I want it, so let's make it. Currently in the basis editor, or the basis engine rather, material shaders and inputs are stored in different places, and that means that I can't do a nice thing like this where I just I have a constant which is just straight up compiled into the shader like this, and this produces like fairly performant shader code when you don't have to go through a constant buffer or anything like that. Just generate the shader straight away with the value hard coded in. It's very nice. Another thing that I don't have, which this makes possible, is shader permutations, because when you have this one graph, you can generate hundreds or thousands of different permutations, sort of slight variations of this shader code here, and you can use them to speed up the rendering even further. For example, rather than having an if statement in your shader code, which is generally bad for performance, you can just have two versions of the shader where one is true and one is false for that particular if statement, and then you select the correct shader rather than evaluating it on the GPU, which again produces faster code. Okay, so this is what we want. And what do we currently have then? Let's go back to our editor here. I'll untick the sleeping, and yeah, I have the selection box unchecked here so that we can see the surfaces a little better. So if we take this rock here, now this has a slightly more complicated shader because as you can see, as I rotate it, it tries to place grass on areas that are sort of flat enough. So now this side has grass. As I rotate it, now it's no longer flat enough, so it just sort of fades away a little bit. So this is a slightly more complicated material, but the ideas are still the same as in our Godot example. And this object is of type rock3 grassy, which we can have a look at in our browser. And I happen to know that it lives in the Rocky Forest blueprint file. So rock3 grassy, let's just quickly make sure that that's the correct one. And yes, it does look like the correct one. So this mesh component here is simply set to use this bin material. And this works quite well. Like whenever this bin material file changes, both the game and the editor can update it on the fly in here. So that path is quite nice. What we actually want to make easier here is everything that happens before this rock3 grassy bin material file is produced. Essentially, what creates this bin material file is what we want to make nicer. And if we look for it here, rock3 grassy, we open it. It currently opens in Visual Studio Code. That's the editor I've been using to edit materials currently. And you've no doubt seen these kinds of files if you watch my previous videos. So, like I said, the auto updating works quite well. We can do essentially like the same thing as we did in Godot by inputting these hex codes here, and I have an extension in Visual Studio Code which just shows me the color here, for example. So you should momentarily see it turn red like this once it goes through the material conversion pipeline. So that's fine, but editing values like this in a JSON file is not fine. And here you can see immediately the thing I mentioned about the current system not having the shader and the inputs to the shader in the same file. Like here we have the inputs to the shader. We have a render pass, which is opaque. It uses this shader program. So it references a bin shader. Okay, but that doesn't tell us anything about the actual shader. We need to sort of make sure to use the correct shader. But here we have the inputs to that shader. So first we have some constants, and as we saw in the Godot example, these could essentially just be hard-coded into the shader. Here we have to pass them through a constant buffer because this shader here doesn't know what we want to pass to it. And then we have some textures, and finally we have a sampler. So this is where we adjust the inputs. But the shader itself lives in another file. So grassy rock is what that uses currently. So if we look at that, we have grassy rock. We have two files. So we have the HLSL file, which is the actual shader file. So here we can see the constant buffer that we used. We have these colors here, and they're sampled in the actual shader code. And then we have the basis shader file, which references the grassy rock HLSL file we just looked at. And it starts with a vertex format. So when compiling the shader, the system needs to know what data is there supposed to be in the geometry of the mesh that this is going to be used together with. And this uses the standard one, which is positioned, tangent, binormal, normal, and then a set of texture coordinates. And then when we have all of this, we can pass it to the shader compiler, which can produce different kinds of outputs depending on what graphics API we use. So we use, for example, DirectX bytecode, SPIR-V, or Metal shading language. And my shader compiler can accept the same HLSL for everyone, so that's why we set them up like this to all use the same file. But you could use different files if you really wanted to. And here we can see that we have a vertex stage and a pixel stage currently for this, and you can set like defines like this. All the other stages are empty. They're not used in this material. But that's kind of the same as going here and looking at this. We have like a vertex. Godot is sort of following the OpenGL naming conventions, so it says fragment, but this is the same as pixel. So they also have a vertex stage and a pixel stage. So we have sort of the same ideas here. We can also see that this opaque pass here has a pipeline state object, which is currently empty because it just uses the default ones. But this is the place where we could put in things like the culling and that kind of stuff that we have here. Here we have the call settings. So these would go into the pipeline state. So we have the data, we just need to package it sort of differently. Okay, so what do I have currently? Well, let's have a look. So I've been working on Material Editor now for 2 days, and this is what I currently have. So I'm using the same sort of UI framework as I use in the editor. You can see these windows. They look like roughly the same as here. You can like drag them and move them around and dock them and do whatever you want. Hide them if you don't want to see them. And that's a very handy open source library called Dock Panel Suite. I'll put the link in the description below. Highly recommended if you're working with WinForms like me. And with this, I've pretty quickly managed to set up the UI so that it should cover all my needs. And this area in the middle, as I'm sure you can imagine, is the node editor area. I'm using another component to create nodes like this. You can connect them together and then move them about and whatnot. And this is powered by another open source library called SD Node Editor. And both of these are MIT licensed, by the way. MIT license and MIT license. So you can definitely use them if you're looking to build something similar yourself. This one is made by someone who speaks Chinese, which I don't. So I've had to Google Translate some of it, but the code itself is quite clear and written in English, so it seems to be pretty easy to use. And I'm hoping that I could actually use this node editor component for other node editors as well, not just the shader editor, but this could be used to do all kinds of scripting and whatnot. I actually already do use node-based scripting for the mission scripting in this game, just not with a self-made node editor. So I'm hoping this could replace the one that I'm using, but we'll see. But yeah, this node editor here is currently not really communicating with the rest of the UI. It's just sitting here, so I can test out that it fits in the UI and everything. But what I currently have here is a way to create a new material, and you can set the vertex format here, and you can set the main render pass, which I currently have as opaque, which if you remember is the same that we have here. So typically an object will have one main render pass and then some other secondary passes, things like the shadow casters and the ambient occlusion. Like an object won't be both opaque and transparent at the same time, but it technically can if you can have it rendered during both those passes if you want to, but that's not really useful in most cases. So here we can, for example, let's leave like ambient occlusion out, and the shadowcaster pass here is by default set to use the default shader, which is the same thing we do here. We set up the pass, but we don't actually specify the shader, the pipeline state, the uniforms, etc. We just tell it to use the default one. And this can only be done for certain passes, such as the shadow map and the AOs and whatnot. You can't tell it to render like a default opaque, because there's no such thing. But okay, we can create this, and we can see that we have like menus here generated for us. Which render pass do we wanna edit? And obviously this node editor would now change when I toggle these. And the shadow map actually doesn't have any shader stages because it's set to use the default one. But the opaque now has a vertex and a pixel stage here for us that we can toggle. And so the next step would be to actually populate this with the correct nodes and all that fun. So so far this has been mostly just boring boilerplate stuff that you need to do when creating any sort of UI application. Obviously the really tricky part will come in the form of generating actual HLSL code from this node graph, and that's something that will be both challenging and fun, I'm sure. But before we can get that far, I want to make sure that I have like the basic UI stuff working, so that actually developing the hard stuff will get easier. And yeah, that's essentially it for now. My plan for this video series is to post an update on how I'm doing with this editor every 2 or 3 days or so. I won't probably be developing anything while recording, because that will just be me spending long times of silence trying to figure something out, and it won't be very interesting content. So I figure it's going to be more interesting for you if I occasionally pop my head up and tell you guys what I did and how it's going. And I'm hoping to actually wrap this first version of the editor up in 2 weeks. I don't really have currently more time to spend on this, but that should already be time enough to actually get some proof of concept version of this up and running, and then I can make small improvements, incremental improvements later on, and that should make it quite worthwhile. But yes, that is my plan. I better get to work, so I'm gonna end this video now. If you have any questions, please leave them below, and if you are looking to do something similar, then by all means check out the links to the libraries in the description, and I'll see you in the next one. Bye.